So let's get started with the second problem. We have, suppose the momentum of a certain particle be measured with an accuracy of 1 part in 1000. Determine the minimum uncertainty in the position of the particle if the particle is, and then we have two parts to that question. Okay. So the first thing we have to notice is that this is a question based on uncertainty principle. So let's write that down first. Del x del p is h cut by 2 or h by 4 pi, since h cut is h by 2 pi. Okay. And what we have is momentum can be measured with an accuracy of 1 part in 1000. What that means is del p by p is 1 by 1000 or 10 to the power minus 3. Or del p is 10 to the power minus 3p. Now let's see the first part of the problem. We have mass and velocity. So we can easily find this p out. Number one, we have p is equal to mv. So 5 into 10 to the power minus 3 into 2 gives us 10 to the power minus 2 kg meter per second. Alright. Now let's substitute all these values into the uncertainty principle. We have del x del p is h by 4 pi, del x is h by 4 pi del p. So substituting the values, we get del x is equal to h is 6.63 into 10 to the power minus 34 by 4 pi into del p is 10 to the power minus 3p, where p is again 10 to the power minus 2. Now if we calculate these, put them in the calculator, we'll get 5.2 into 10 to the power minus 30 meter, 5.2 into 10 to the power minus 20 angstrom. So that is the answer to the first question. Let's look at the second part of the question. We have electron moving with a speed of 1.8 into 10 to the power 8 meter per second. Again, the first thing you notice here is that this value is very close to c, which is the speed of light. So this is a relativistic case. So in this case, when we're doing p is equal to mv, m is the relativistic mass. So let's write that down with rest mass. So m is equal to m0 by root over 1 minus v square by c square v. And m0 is just the mass of electron now, which is 9.1 into 10 to the power minus 31 v by root over 1 minus 1.8 into 10 to the power 8 by 3 into 10 to the power 8. Let's take a square of that, and the value we get is, let's just write 9.1 into 10 to the power minus 31 v by, this comes out as 0.8. Okay. Now again, we're just going to substitute this in the uncertainty principle. Del x is h by 4 pi del p, 6.63 into 10 to the power minus 34 by 4 pi into del p is again 10 to the power minus 3, and now p is 9.1 into 10 to the power minus 31, v is 1.8 into 10 to the power 8, and this 0.8 goes on top. The value we get is 2.5 into 10 to the power minus 10 meters, or 2.5 angstrom. That is the answer to the second part of the question.